All right, so I've got a thumbs up. That means we can start. So, welcome to this talk. I've titled it a retro introduction to WebAssembly, and those are two things that don't really tie together. We're going to try and tie them together in this talk. One of my main goals for this talk was last year I gave a talk that required 15 kilograms of video gear to do demos. And this year I wanted to go in the complete opposite direction and see if I could give a whole talk that just uses the web browser for demos. And we'll have to see whether or not I succeeded at that. As well as giving you an introduction to WebAssembly, today I'm going to give you an introduction to 90s music technology, whether you need it or not, because if we're going to make things run in our web browser, we need something to run there. So, but to start with, I'm going to give a brief overview of what WebAssembly is, if I can press the right button on this thing. So WebAssembly, commonly known as WASM. Why do we need WebAssembly? Because Flash had many, many issues, but at the same time, people still like to watch videos of cats. So the internet needed a new way to watch videos of cats, and WebAssembly was born. But also, I remember a time in high school where the internet was just starting to become cool, and you could do crazy fun things like go to the website for Darude and play music for 3 hours off the web browser, which, when you're at school and had a limited selection of software, was kind of fun. You could also go in and configure a custom car and all sorts of things using Flash. And so WebAssembly gives us a way to do those cool, fun things that you don't want to write in JavaScript. So a bit more about WebAssembly. It's an open standard. It provides a sandbox environment. It enforces the same security policies as your web browser. And you access browser functionality in the same way as if you're writing JavaScript. So in this particular talk, me being a C++ developer mostly, we're going to talk about mscripton, which helps us port C and C++ libraries or programs, especially if they're using SDL and SDL2, to the web browser. If you like Go, or you like Rust, or you like pretty much any other language, there is a way to take that and turn that into WebAssembly, but I'm not an expert in it, so I don't know. I'm barely an expert in this. So basically what mscripton is going to provide us with is an LLVM-based compiler toolchain. So it gives us a way to convert our C++ code and output WebAssembly. It also converts OpenGL implementations into WebGL, because you need websites to be able to use your GPU, because that's fun and you can do weird things. And if you've ever seen one of my talks, I'm all for fun and weird things. And so it implements a common subset of libraries such as SDL2, pthreads, and a lot of POSIX commands. It also provides us some shell scripts to set up a common compiler environment variables, and wrappers for tools such as make, cmake, and configure in order to make compiling and building your software for WebAssembly as simple as possible. But as I said, if we're going to take some software and run it in a browser, then we need something to run. And this is where we're going to start to come into trackers. I think a bit of background I missed in this talk is one of the other things I like about conference talks is you can go to a talk, you can be inspired to start a random side project and just have a bit of fun and maybe learn something. And that's what this project was for me. I saw a talk at Everything Open in Australia from Katie Bell about WebAssembly, which I knew nothing about, but I always found assembly interesting, so I went to the talk. I learned something. And trackers is also something I was introduced to at a talk. And so I'm going to give you a basic introduction to what tracker software is. Basically, it's a music sequencer and arranger was first popular in the late 80s, early 90s on Amiga systems. Around that time, you finally were able to buy cheap sound cards to input audio into your computer so you could use a computer to make music. It was used a lot in the creation of music for the demo scene and for games of the time. It was also pretty influential in jungle music. And so, as it would happen, openSUSE Tumbleweed is a wonderful distro that has one of many things. And some of the software that is still included is a tracker. This is Hively Tracker. There's Pro Tracker, Milky Tracker. There are many tracker software that run on modern Linux systems still, but this just happens to be the one that was in a package manager, so it was easy. And I downloaded a little song here, and we can hit play. And sorry, Mr. Sound Guy, that was very loud, very quickly. But you can see here we have 6 channels, and they can all play different music. I'll let it loop back, and then we have our sections up here. And once you have the muscle memory for these programs, it is actually quite an efficient way to write some music. And so this is where trackers started, but for the purpose of this talk, it's kind of not quite where we're going to go. So the next thing that came along that is so old that I couldn't even find a Creative Commons licensed screenshot of was something called LSDJ. Now, people wanted to make music when they were out and about and going places. In the early 90s, there wasn't many devices you could do that on, but one device you could do that on was the Game Boy. So someone wrote a version of tracker software for the Game Boy, and continuing on from that, someone thought, I like that interface, I'm going to keep it as sort of other handhelds and other devices like PlayStation Portables, this sort of clone thing came around. So rather than using the Game Boy's game engine, someone wrote Little Piggy Tracker, which was inspired by LSDJ. The user interface is very similar. These days it works on Raspberry Pi, Linux, OS X, Windows. My interest came into it when I ported it to one of these little Chinese knockoff handheld things that is kind of an Orange Pi in a nice case. I will go into that a bit more later. But so we have Little Piggy Tracker, which again I can show you. We're going to ignore the fact that this demo needs to run in GDB. And so here I have a USB Super Nintendo controller, and it is not going to work, so I'm going to have to use my keyboard. And I think that is one. And so here you get a similar idea. You've got your 8 grids of different channels. If I hit play, we get a song. You can see the notes that are playing down here. This left one here is sliced up drums. Then there's a synth and a bass. And so I can come across here and we can see all our notes that are playing. And again, you can put together different chains to arrange music that way. And so this is Little Piggy Tracker, a tracker designed for your handheld devices. And so basically, the whole reason we're here is after seeing that conference talk by Katie about WebAssembly, I thought, I've ported Little Piggy Tracker to many different things, including SDL2 and these devices. I wonder if I can make it run in a web browser. And so that is the whole premise of this talk. But first, we're going to take one other side track. We just had a talk about open hardware. So this is called a Pico Tracker. It is how I found out about Little Piggy Tracker. This is an open hardware device that will run a custom version of Little Piggy Tracker and is a nice audio thing. They're going to come out with one you can buy soon as well, but this is a kit you can put together with a 3D printer, and it uses a Raspberry Pi Pico. And that's how I got here, so I figured I'd give that a shout out as well. So we want to port LGPT to WebAssembly. Now, LGPT has manually written makefiles. As much as I don't like manually written makefiles, these ones work, and they haven't annoyed me enough that I've gone and added a proper build system to them. And so basically all we had to do was, instead of pointing at a C compiler, we point at the script and C compiler and C++ compiler. We need a couple of extra flags to say we want to use an SDL2 port, and we need P threads. And similarly, down the bottom, we have a few extra linker flags. And we're going to say we want to use emrun, which will help us set up a basic web environment because we're too lazy to write one of them ourselves. But there is one other change we need to make to our software. Fundamentally, graphics applications generally have their own event loop that locks forever. Web browsers get very annoyed if you block forever and you don't give them some control occasionally. So basically what we have to do is we have to take the code that would have been our main loop and use this mscript and set main loop function, and then it will integrate us into the web browser's main loop. And in the same way, if your SDL app is polling for events and sitting there waiting till an event comes in, it can't do that. You need to use wait event. But other than that, that may be the only couple of things you need to do to port your code. But thirdly, if we're making music software, we want to be able to upload some data files. And so here is some additional rules in the makefile that tells us we want to preload all these config files and some samples. And so with that, we should have a demo. Now, if I go to the right, so we can see I can make, that is the wrong spot. Let me just, the demo is still running, so we're going to kill that for a second. So we can see I can run make, yep, looks like you're compiling anything else. And then we're going to use this emrun function, which is going to set us up a basic web server and load our app in the web browser, which is fantastic. Unfortunately, yeah, the controller doesn't work with this either. But unfortunately for me, we get this far, we get some graphics. Unfortunately, LGPT is kind of fussy about audio formats, and it's very opinionated. WebAssembly is also kind of very opinionated about audio formats, and so we get this far. We can start to write a new song, but when we come in and we try and load our sample, you can see we don't get proper playback. Now, because this is just a fun project for me, it would have been cool if we could run this in a web browser as a demo, but I spent a day or two messing around trying to get audio to play nicely, but then I decided, as a fun demo, this was great. I have learned some things. I don't need to use this, so I'm not going to spend any more time getting this working, which doesn't leave us with a great thoughts and confidence for this conference demo, and it is a pretty crappy way to end a talk. So we're not going to end there, and I started thinking about what other SDL2 apps could I port to run into a browser, at which point I found there are crazy, weird people like me, because there are crazy, weird people that have already ported some apps to run in your web browser. And so we're going to have a look at a couple of those. Firstly, that is the wrong tab. Oh, yeah, that's right. We're over here. So firstly, we're going to have a look at everyone's favorite. Can you run an operating system in your web browser? Yes. There is other demos of this. Welcome to DOSBox. I thought it would be fun if I could run one of my favorite childhood games, Jazz Jackrabbit, from in a web browser, because why not? So we're going to mount some things. And here we go. We have a DOS game. It is running in our browser. I have the CD for this, which is how I got all the assets and so forth. And one of the reasons, tying back to everything before, one of the reasons I like this game is the music. And incidentally enough, Jazz Jackrabbit also used the tracker for its whole soundtrack. Eventually, we'll be able to play a new game, and the key binding is going to map wrong, and I'm going to be crap at it, is going to be my excuse. But we can approach Diamondas. And if you had the shareware version of Jazz Jackrabbit, you will remember this. Here we go. I could spend half an hour playing Jazz Jackrabbit in DOSBox in our browser, but that's not what we're going to do today, because we're here to talk about 90s music production and browsers. So one of the things about Jazz Jackrabbit, as I said, was it used a tracker. Because if you think about it, when you used to ship your games on a 1 1/4 inch floppy drive, and you only had 1.4 meg of space, you didn't have a lot of room for audio. So you couldn't just ship WAV files of your full audio soundtrack. You had to do something else. And fortunately for us, we're going to look at another piece of DOS software, because why not? Fortunately for us, someone converted all of Jazz Jackrabbit's audio files to run inside another DOS tracker program. So we have a look here. We need to swap to the C drive. I used DOS for a long time. You'd think I'd still remember how it works. So we can launch Scream Tracker and press any other key to continue. And again, we want to load a song, which, here we go. So over here, if I don't go too quickly, here we have all the tracker files for Jazz Jackrabbit. And so we can come back down. We heard the menu before. We can hear the menu again. We can press F5 to start playing the music. We can see a couple of channels. We can see the samples that are playing. You can come through other views and look at how they wrote out their notes to play their music. And this is how the soundtrack for 90s video games was made, which, again, fun as a demo. But at the start, I mentioned OpenGL. And really, we couldn't not have a demo without some WebGL and some fun from that. So does anyone here remember the media player Winamp? Does anyone here remember the visualizer for Winamp? That just happens to be open source software, which, again, someone mad like me decided should run in a web browser. So we'll open up. We will start our visualizer. And then, for fun, let's start some music playing again. And I hacked this to add an enable microphone setting. So now we have audio reactive visualizers in our browser. And again, I don't entirely know how or why this is useful. I think in terms of legacy software and giving people a way to run legacy software without having to compile it all, that's great. And so, yes, I guess this is useful. I had fun. I learned some things. So from that perspective, it's also useful. We'll stop the music for a second, and I'll come and see if I had any slides I missed, because it's kind of important. Yep, we had our beta demo. If you want to run EM-DOSBox, here it is. It's pretty easy to compile. Again, we do they've written this nice packager script that lets us I took the copy of my Jazz Jackrabbit CD-ROM and put it in my downloads folder, and then pointed this packager at it, and it automatically sorted out all the data files for me. So that was great. Also, instead of using the EM run we used before, you can just start a Python HTTP server, or probably a better HTTP server if you were actually going to use this in production rather than to mess around with. And here is a link to Project M, and the other part of the talk. So I wanted to talk, originally I was going to give this talk about this and porting trackers to this, but that was a bit less fun. I would encourage you, these things are great. There is an app on GitHub which will give you SSH access. They use the default user and password for a Raspberry Pi. They run Ubuntu with some hacked up SDL too. But so far from what I've found, any SDL2 application you can run on one of these guys. That's fun. I also ported DOSBox and Jazz Jackrabbit to this and can play that with a keyboard because I never got to the keyboard mappings. But yeah, I thought I'd give a shout to that at the end. I'm lazy. I installed GCC. I mapped an SSH file system to compile things on, and I had fun building things for this. So with that, that is the last slide. Does anyone have any questions? If not, thank you very much.